In the last video, we really started our foundations on Boolean logic. We're going to continue those foundations in this video here, where we're going to be going over if statements. I've used the term conditional branching to describe if statements, and essentially what I mean by conditional branching is that it allows us to choose which part of our code executes with these if statements. The conditional part of it is really just referring to the Boolean logic that we've been going over, so like Boolean expressions and things like that. And then the branching is just talking about being able to pick and choose which part of our code is executed. In all of our programs that we've written so far, all of our code has been executed line by line from top to bottom in a linear fashion. With if statements, this is still pretty true in the sense that it is executed in linear fashion. The only difference is now we can actually pick which lines are executed, or we can change the outcome of our programs because of these if statements. Let's go ahead and get into some examples. So for this example, I'm going to do a very basic one, and you might see this in other places. It's a very common practice with making if statements and using them. It's essentially just going to tell the user whether or not they are an adult or maybe a child or a teenager, depending on which age they input into the program. So to do that, I'm actually going to have a variable called age, and just like we would, I'm going to set this to an input and cast it to an integer because, ages are whole numbers. Typically, no one's really going to give like a fractional or a decimal value for their age. So I've gathered their age and I've casted it to an int, so we know this is going to be a number. Now let's go ahead and first let's maybe say like tell the user whether they are an adult or not. So the first keyword we're going to do is we are going to actually start this if statement with the if keyword, like you may have thought. This is why it's called an if statement, is because we use this keyword. So whenever we use this if keyword, we have to follow it with a Boolean expression. You can use any expression that returns true or false, and we went over a wide variety of those in the last video. So if you don't have a basic understanding, or if you're uncomfortable with this, I highly encourage you watch that video or practice it on your own before really getting started with if statements. So if we just want to tell the user whether they are an adult or not, the expression that I would pick is if the age is greater than or equal to 18, because in at least where I live, you're considered an adult if you're 18 years or older. So I'm going to say if the age is greater than or equal to 18. So you see I just inputted a expression here like we went over in the last video, and then you'll notice that I have a colon here. This colon is going to signify what's called a block of code. In some languages, this is denoted with curly braces, but in Python, to simplify the syntax, we just use a colon, and you'll see that your editor probably automatically indented. If it didn't, the standard convention is to either use 4 spaces or just 1 tab in. Tabbing is especially important in Python, so make sure that whenever you have a block of code like this, you only tab in once unless you are going within a colon. So for example, I could nest an if statement here and just say like, we'll just say if true, because that is a valid Boolean expression, and you'll see that it goes 1 tab farther. Obviously, I'm not going to do this, but that is possible. While we're talking about blocks of code, I'm just going to go over a term called scope really quick. This has really nothing to do with what we're going to be dealing with now, but I figured I want to get this definition out of the way and get you just familiar with the term. So scope refers to a location in your program that a variable or like any data is restricted to. For example, this out here, this age variable, is in what we call the global scope. And the global scope means that it is accessible by anywhere in the program because it is fully to the edge of the line. So it's not tabbed in at all, and this is why it's in the global scope. This, if I were to create any variable or whatever, I'll just say like I equals 0. This I is in what we call the local scope of this if statement. This isn't really going to come into play at this moment, at least for what I'm going to be going over. It will later when we talk about loops and functions. But just to get you familiar with the term, this is in the global scope and this is in the local scope. And it just refers to where variables can be accessed from. So let's go ahead and remove this and then do what we originally wanted to do. So maybe I'll have a message that says like, you are an adult, and I accidentally hit the key to open up a Python terminal. So I'm going to go ahead and run this and let's see what happens. And it actually threw a message threw an error because I was still in the Python interpreter here. So I'm going to clear this just for the sake of clearing it and then run it again. And it's going to ask me to enter my age. So if I do 18, it's going to say that I am an adult. If I rerun this and I put 15, you're going to see nothing happens. And this is because we just didn't tell the program to do anything. So let's fix that. Now let's expand our example here to fit in whether you are a teenager or not. So what we can do is we can say if the user is in between a certain range of ages, then they are considered a teenager. And for this example, I'm going to use between 13 and 18. And then if you are 12 or younger, then you are considered a child. So for this, I'm actually going to use a new keyword, and this is the Elif keyword. So this Elif just says, if you have a condition that is going to be different than this main condition in the if statement, then I'm going to give you the option to make another condition that can satisfy the criteria. So we want to make the user a teenager if their age is in between 13 or 18, but we want 13 to be inclusive because if you are 13, then you are a teenager, but if you are 18, then you are an adult. In math, you've probably seen this notation before when dealing with domain or range, and you can do this exact same notation in Python as well. So we want to see if age is in between 13 and 18. So I'm going to start this with 13 as our minimum and say that that is less than or equal to age, and then age is going to be less than 18. And the reason why I'm doing just less than is because I don't want it to be inclusive, because if you're 18, you're an adult. Inside of here, I can set a print function to print out, and I did it again to print out you are a teenager. And then let's go ahead and clear this and run that and see what happens. So we've already determined if you type in 18, you are an adult, but let's run it again and type in 15. It's going to say you are a teenager. So you'll see that now that we have more criteria for this to fit in, it really picks and chooses which line of this is executed. So now I'm going to introduce you to this last keyword, and this keyword is called else. So else, you might understand this to be that it accepts anything that is not satisfied by either one of these conditions. And it's also important to note before we get into this, you can have as many Elif statements as you want. So I could have 3, 4, it doesn't matter. As long as I have any condition that I want to catch, then an Elif is good. And Elif just stands for else if, but it's shortened. So with this else, this is going to get executed if all of these conditions return a false. So in our case, if you aren't bigger than 18 or in between 13 and 18, then this is just going to catch everything else. So in this case, we want to print you are a child, right? And then now you'll see that if I enter in 7 or 4 maybe, this is not caught by any one of our conditions in the if or the elif. So I run it, it's just going to say you're a child. This is a pretty straightforward implementation of an if statement, and you can actually use any Boolean expression that we've gone over, or maybe if you're using any libraries and it has certain functions, you can do any of that. As long as it returns a true or a false, you can use it in an if statement. Some of the expressions that we went over in the last video were pretty long. These are pretty basic, but I'm actually going to talk about how to shorten your if statements. We've already went over one way, and this way is using this notation here that you've seen in math. The equivalent to this, if you didn't really want to shorten it like that, would be more of a elif age is greater than or equal to 13 and age is less than 18. That would be the longer way of doing this, but this is just a shorter way, and I just snuck that in because it is easier in my opinion than doing this. But there are other ways, and we're going to get into those right now. So let's go ahead and comment all of this out because we want to start with a new situation. We can actually do a really different problem, and I wouldn't really recommend doing this quite yet, but we're just going to do this for the sake of example. I'm going to maybe make a variable called like is snowing and set that equal to the input of is it currently snowing outside? And we're just going to let the user put in like yn. So then in here I'm going to have an if statement that says if is snowing is equal to lowercase y, then we're actually going to just set this equal to true. And then we want to use an else. And just for the sake of catching this, we'll actually do an elif here. And we'll do like elif is snowing is equal to in, if I could type. And then we're just going to set this equal to false. And then one last condition, say maybe the person didn't enter y or in, then you could just print like that isn't valid, and it'll be the same. So here, now that we've made these into booleans, and like I mentioned, this wouldn't be anything that I would put in production by any means. This is more for the sake of example. But let's have another if statement down here that says, well, if it is snowing, then we can print it's snowing. And then the else will just be if it is false, then we'll print, oh, what a bummer. So you'll notice that I didn't do if is snowing is equal to true. And I could have done that if I wanted to, but it's actually understood that you can just remove the true and just say if it is snowing. This is more idiomatic and more common, and you'll probably see this in real code. So it's just something good to know. So then now if I run this, and I just really want to stress that this isn't good code by any means. I wouldn't recommend writing this if you had to ship something, but it is here for an example. So I'll run this again, and let's say it is not snowing. So then it's going to say, oh, what a bummer. I'm actually going to space this out so that it looks a little better. And then I'm going to run this again, and this time I'm going to say yes. And you'll see that if I do that, it's going to say it's snowing. But then what happens if I don't actually do y or n? I just type in anything like f. You're going to see that it's going to say that isn't valid, but then it's also going to print that it's snowing. So why is it going to print that it's snowing if we didn't actually initialize this or set it equal to true or false? Well, that's because if something isn't a Boolean, but you are checking for if whatever, so for example, I can just have like, make another example down here, like I is equal to 1. If I, then print yes. And then we'll comment this out one more time, and then we'll run this and see what happens. You're going to see it's going to print yes, and that's because if a variable is initialized to a value, then it is automatically declared true. So if something is not a type Boolean, but it's like a string, for example, because we never actually casted it or changed it to a bool, it's still a string down here. And since the string is going to be initialized to something because I set it to that, because I typed in a value to the console, it's going to say that it's initialized to a string like the message that I typed in, and then it's going to evaluate to true. If we set this equal to 0 now and try it, you're going to see that nothing happens. And that goes back to the comment that I made before, mentioning that Booleans really just turn binary ones and zeros into a true or false. So since 0 in binary really is false, it's off, then it's going to evaluate to false. And we can actually test for that by typing in if not I. So this says if it equals false, then we want to satisfy this condition and print yes. So now you'll see if I run it, it's going to print yes. And that's because I put not in front of it. And not just reverses the evaluation of that expression. We can also do this with a string here and really just any value in general. And you're going to see that it also doesn't print anything. And this is because if it is set to the default value of that data type, it's not going to be counted as initialized. So an empty string with just quotes, and this could be double or single quotes, there's nothing actually in the string. So it doesn't really count as initialized, just like it's not evaluating the yes. I can do this with a list, and you'll see same deal. This is just the default value of this data type, so it's not going to do anything. So the default value for an integer is a 0, and then the default value for a string, I'll actually rename these, so like I'll call this like num equals 0, string equals empty quotes, L equals the brackets, and then we'll do like I actually call this N S L. We'll do T is equal to parentheses, that's an empty tuple, and then we'll do D for dictionary, and that's the same thing. These are all the default values to the data types in Python. I went ahead and commented those out and made a note on here so that we can just keep a note of that for future reference. So those are really all that I wanted to talk about on the normal if statements. Just another note, you don't have to have an elif in a statement like that. You can just have an if or an else. Or if you want, you can just have an if. You don't have to have an else. But in order to have an else, you must have an if to match it. We can also make one more shortening of an expression, but it's not necessarily a Boolean expression. We can actually shorten if statements down into one line. So I'm going to use my example from before with the whole adult thing. So I'm going to set two variables. First, I'm going to have age here, and I'm going to cast that to an int, just like before. And then I'm actually going to have a second one, and we're going to say like is adult, and I'm going to default that to false. So now I could just do a normal if statement here and type in like if age is greater than or equal to 18, then is adult equals true, and then else it is false. Since it already is false, we could just have a keyword called pass in here. That's not a comment there. We just have a keyword called pass, and I'm not going to get into pass right now. Pass really just means to just essentially skip over it. But for the sake of this, now let's go ahead and print out what is adult is. So now I can go ahead and run this, and if I run 18, it'll print out true. We already knew that that was the case. We knew that that was going to happen. But how are we going to shorten this? Well, we can actually get rid of all of this code here and just have the is adult variable. Now, if I want to make all of that into one line, which I can, and this is going to be more idiomatic, I would actually put the value that I want first. So I could put true, and then the condition that it's going to want to be true for. So I want to set it to true if age is greater than or equal to 18. So that has our first condition, and this is the only instance where you will need an else statement. And then I can put else and then put the value that I want it to be if it doesn't satisfy that condition. In some languages, this is called a ternary operator, but in Python, since this isn't an operator per se, it's more of a statement, I will refer to it as a ternary operator, but this is more of just like a more idiomatic way to write an if statement on one line. So to prove this, let's go ahead and run this, and we will go ahead and enter 18, and it'll be true. But what's going to happen if we type in 10? Well, it's going to be false, because we told it if it's above 18, set it to true. Otherwise, no matter what, set it to false. This isn't bound to variables. We can actually do this with just about anything that's going to require an if statement. So I could, in here, instead of printing is adult, I'm going to delete that entire variable, and then I'm going to print true if age is greater than or equal to 18, else print false. And you'll notice this will have the same exact effect that we had before. I'm just not storing these values in a variable. Go ahead and put this in here, and it'll print true. And this could be anything. I could put in here like you're an adult. And then instead of false, I'll just print like you're not an adult. And then we'll try this again. And I'll try it with 10 this time, and you'll see that it will print you're not an adult. Like I mentioned, this is really good for if statements if you're just going to have an if-else block and you only are having one line of code within those blocks. And it is just overall idiomatic, and it will make you look like a better programmer if you use these little lines in your code. It not only makes it shorter, it just makes you look better as a programmer, so I highly encourage you to use them if you're comfortable, but it's not really a big deal if you don't use them in your code. I gave you a few basic examples of what if statements are in Python today in this video. I encourage you to practice these on your own and write more complex statements. You can combine these with ands, ors, nots, or really just any Boolean expression, and try and make more sophisticated programs. We're just getting started in writing fleshed out programs, and we are getting closer. This is a really good first step for that. In the next video, we're going to take a break from all the programming, and we're actually going to talk about just an important factor in programming, and that's just understanding errors.